Hello there everybody. Hello retro coders. Back again with the double buffering. I think I've nailed it. Hence the title of the stream. I've got a new streaming setup. I've had a quick play around. I've been back for half an hour messing around with the mic. It's really tricky to do it. Even recording little videos over and over again and hearing it sounds okay to me. I'll be guided by you lot. If it's bad, I'm sure someone will tell me eventually. The main thing is you can hear me, but it might get a bit too loud maybe. But anyway, this time around I've got a working implementation on my system. Excuse me. From fixing this one that I've made, I kind of gathered that I think I went wrong last stream, which was just on the drawing spikes routine, not actually the double buffering. What would happen was I was timesing Y by 32, which is what you would do if it was using all of the screen, but we'd cut it down to 28. So I think we needed to cut, if we're going to times it by 32, we'd need to then actually reduce it, just decrease it by 4. Anyway, let's not talk about that because it was last time around. Starting a fresh, complete project here. I'm going to try and keep it very much tidier. Calling it buffertest.asm. It's going to be available on GitHub at the end of the session. As always, we'll create our constant entry point, and I'm going to put it at 9,000. That gives us 2 segments worth of screen memory that we could buffer. I am considering just ditching using hex, but for me it's easier to visualize. Although it is harder, I couldn't just tell you how much that is in decimal. I mean, it wouldn't be that hard to figure out, but it's what calculators are for. But sometimes it is probably better in decimal, but I'm going to stick with hex. It makes no difference to the program, of course, but if you're watching that and you're a newbie and you're thinking, what the hell's he on about, it doesn't matter how I write that, whether it's decimal, hex or binary. I've never tried to write it as binary. I'm pretty much working straight off my working one here, but we've seen all of this stuff before. So I'll clear the screen. I've actually started to get into the habit of just putting a label in it, so I could jump back to there if I wanted to later on to just restart the program. Already I'm going to have to make some constants, and I'm going to put it in a new file. I'm not going to use folders, I'm just going to put it all in this one folder. I'll just write it there, it saves me writing it when I save it. There we go, saved. The constants. For now, I'm starting to keep a collection of useful constants, so I don't need to constantly keep writing this, and also so I don't need to remember what colour's what. This is where I do miss Visual Studio, because I'd be able to just click that and it would highlight just that one bit of it, if I remember right, knowing that I was just going to try and do these renames. You could also do, you could hold Alt and go down and delete them all, but this doesn't manage to do that for some reason. Notepad++ does. I'm not one for using a mouse. I actually hate using a mouse. Like, it slows my productive. I absolutely hate it. I prefer to just write code if I understand it well enough to do so. Obviously, when you don't, it's nice to have a UI. But all this node-based programming, it's not for me. Hello, Moz. Good evening, my son. Yeah, I think I've nailed it. Hence the question marks sneakily there, just to cover myself. I had this chat obscured because I'm actually copying a lot of the code here, just word for word. When I got home from work, I looked at my code and I realised there was just one stupid error, and I changed it. I won't spoil what it was yet, but when I get to it, I'll point it out. But I changed that as soon as I got home, and it immediately fixed the problem. I also noticed when we're getting them little tiny graphical glitches like we were getting before, it's all about the amount of frames you delay, and there's no logic. I haven't worked out the logic to it yet. Well, it seems like you have to allow adequate amount of frames for it to draw everything. But I'm doing a tiny buffer here, and I'm sure the Spectrum can handle more than what I'm doing, but I was already having to put it down to like 4 frames weight, which is, like having 4 halts in there. So it's definitely not perfect, this, but I think it's a good like learning example. It's very small. For this constants file, I literally am copying it word for word, but I am going to type it in, not just copy and paste. This is important that we're doing our screen buffer values, the constants. The game area will be 16 by 8 character cells. Is that even how you spell it? It looks weird spelled like that. Oh. So this is only a tiny little buffer, a tiny screen. It's like, it's half of one segment, isn't it? And a segment is a third of the screen height, so it's like 1/6 of the screen basically. But I do remember like a tank game, it had yeah, you're dead right there, Moz. Couple of hours away from it, and then bang, got home. It was like a light bulb. I looked at it. I almost want to tell you what it is, but it was. I'll spoil the fact that it was in the draw sprite function. It was nothing to do with our buffering. And in fact, I expect the other code would work if I just made this small change. Although I did start messing around, changing loads of things, so I found it better just to move away from that one. But, yeah, this one's the reason this is going to be so much easier to understand is because this sprite I'm going to draw is only going to be 8 by 8, so we don't have to do any of that shifting along one and then back one and down a line. And the same goes for the lines. I'm only drawing 16 character cells per line, so we can fit it all in one push pop, whatever we were calling that, the stack pointer when we were doing that. So it makes it just so much less code. It's unbelievable. Yeah, so we've got our game area. We visualized it in our head here. We've got 16 by 8. That's the sort of key fact. And we're going to call it play window from now on. Well, I am anyway. So it's play window start. That just means where does the memory start for the play window. I'm not quite sure why I didn't put that Also, that's completely wrong. It should be 84. That's why, yeah, 400, which is half a segment. So I've only allowed exactly the amount I need. I mean, that's only a constant anyway. I don't even think I use that particular one. Now we'll just do the UV version of the same thing. I mean, I make up these conventions. It would be so funny, like years down the line, to find people using them. I'd find that so funny. But I mean, it is helpful to see, oh yeah, that's the upper pipe. I mean, it's obvious, but it's meant for those who are just brand new, just to figure it out. Might help someone figure it out. Same as this was an unneeded constant, but it was kind of helpful just to visualize things. I'm also doing a margin size so that we can move it. It's only a small window. We could have it in the center of the screen, for example. But at the moment, I'm going to keep that at 0. I think that says it all, but that's the actual video memory start of each segment. Should put this up here. I should probably call it play window width as well, not window width. So obviously that's in characters. We use that somewhere down the line, that's why that's been specified there. And then I think just for tidiness, I don't think I ever use this one either, but of course you can come back and delete the ones you don't use at any time. I'm not sure a constant even uses any RAM or space on the table or anything. Because I don't see why it should. A compiler should be able to just paste that everywhere when it needs to. Yeah. So I've times it by 8 there, just to demonstrate that it's in pixels. I mean, obviously I could have just wrote 64 or 68 or whatever that is, but anyway. I named these this, just it meant something to me at the time. So I had line down offsets and char down offsets. So what I meant by that was when I'm moving down one line inside a char cell, what's the offset I need to add? And then this is when I'm moving an entire char line down. And it's strange and counterintuitive because the line offset is much bigger than the char offset, just by the way it works. I won't show that pixel drawing routine we've done, but we can visualize that, how it draws it. And if someone's here watching that live not knowing what I'm talking about, go on YouTube on my channel, look it up, quick demonstration of the spectrum memory, and then you'll find it there. And also last night we've done all these variables except for they were called P1. I don't know, I think he called it P after pixel. I call it line. So I know I'm moving down a line, pixel could be going left, right, or up and down, you know. I mean, it can't. The way we're writing this code, there's actually no way of moving to the right by 1 pixel, I don't think. But we can deal with that at a later date. So let's just get all these out of the way. So in other words, crazily, if you're on the first character cell, line 0, you're at 0, 0 in the memory. I know it's actually 4x, 4000x, but let's pretend it's 0. If you're on 0, line 0, you're at 0. But weirdly enough, line 1 is 256 bytes away in memory. And every other line is a further 256. Which is odd, because there's only 32 bytes in a line. Just got to get used to it. It moves down a char before it does the second line of each. So anyway, that's why this is only 32. And so on. C5 Clive. I mean, I just think it's not worth copying and pasting this code. It's not that big. I could have just copied and pasted all of that in, but then people might not miss. There might be something I didn't explain. I'm going to roll my ciggy. I've almost run out, but I've got a tiny bit lying around here somewhere. I think my hotkey for muting has gone out the window. Yes, it has. Okay. So Constance is complete, and it really just covers the video memory and screen buffer. It also has one value for our vsync routine, and then these are just convenience values for the colors. Yeah, good shout, Moz. It's insane how convenient Hex makes things for the. It's just weird. My mind blows with stuff like that. Like, it's all too perfect. Some people are so clever, like the actual inventors of all this, you know. Yeah, I should have written it in decimal, I think. I'm trying to get out of the habit of it completely. For when you're addressing a memory address, I like to just use hex. Don't know why. Same if I put a value in there, really. Like when I started out doing this sort of stuff on Nintendo modding NES games, you know, almost just cheat engine style stuff. And it was just always hex. Every value was hex. So you just get used to it, don't you? But they were always only 8-bit values though. There was like maybe the odd 16-bit. Yeah, stick the hex in it. Way to go. I mean, occasionally it makes sense to use another notation. Um, I've just noticed something weird in my example as well, and it's worried me a little bit because it goes against my understanding of what I did, but it seems to be working, and that is by putting one halt in the main, and then using the vsync function to hold as many frames. I suppose that does actually make sense, because then you're sort of guaranteeing how many times that sync. Well, the sync function should work independently from halt, because it actually counts the what's we called it? Counts the built-in frame counter from the Spectrum. Anyway, right, let's get into this. We're not far off getting right into it. All I did here, straight after clearing the screen, was I just changed the colour to black for the border. Oh, and I created a function called set border colour, a routine. And what I did was I put that into tools. I made a new file, tools.asm. Set border color. Now, normally, if you're a good programmer, especially if someone else is going to be either reading your code or even worse, using it, you would comment, But so it sets border color to value in accumulator, just in case. I mean, that's a really obvious one, but it's a good habit to get into that. Trust me, for your own benefit. When you come back to it. I mean, quite often I laugh. I come back to something a month later and I laugh at the rubbishy notes, because you do, like Moz said earlier, you seem to understand it better sometimes when you've had a long time away from it, and you jump back in thinking you're not going to even understand any of it, and you think, oh, that's where I went wrong straight away. This vsync routine very slightly confuses me still, and that's why my comment just says vsync routine. But basically, we have a variable called previous frame count, and this is where I get confused. I've read this from Jonathan Caldwell. He knows what he's doing. He defines it as a byte, but in the very same paragraph above where he shows you how to do this, the exact same paragraph, it says frame count, is a 24-bit number built into the Spectrum, and it increments once every 50th of a second, no matter what. So it's like it's trying to sync to the television in the old days, basically. And it would count. There's no actual way of knowing when the scan line's on the Spectrum. It hasn't got a way of knowing what the TV scan line is doing. But it's done the next best thing where it's got this 24-bit number. I mean, that goes up to God knows how much. I did look it up at the time, but it's millions, I think. I'm going to have to look it up. I can do it on my calculator. Probably would have been quicker looking it up on any other system. I think it goes up to 16.777 million. 16.7 million. So yeah, and then it'll just reset back to 0. And all we're checking is that I've just closed my notes. Like 5 or 6 frames at the absolute most. That would slow us down to like 10 frames per second if we checked 5 frames. But we'll do that now. So we've created this. This is just going to cache our previous frame count when we last checked it. I've named it the routine sync. I might even just stick that there like that. So we'll give it the pointer of this. this is the built-in function I was talking about, the built-in frame counter, and that, as I say, it's a 24-bit number, so I'm really confused how A, which is an 8-bit register, can take the value in that. It must be, he doesn't explain it in the book, but I think that must go to the lowest byte of the 3 bytes. So we're only looking at the bottom 3. But in that scenario, there is a chance that it could count up and go to 0, doesn't it? But I decided not to worry about that. It works. So all we're doing there is subtracting the value in the genuine frame count from our cached one to find the difference. Did I already create frame delay? Yeah, see, for this purpose I created frame delay so we can change it there how many frames we want to wait in each loop to allow our code to be completed before we try and draw it again. Do I need to comment that one? A equals current minus previous. Can't spell. Oh my god. It's because I've got a microphone in my face. I can't see the key. Yeah, and then, like I say, I made that especially we compare. So A became just the difference between the two, and then we compare it to our number 2, or whatever we set that as. If it's more than or equal, we'll jump to sync end label, which we'll make in a minute. If it's not more than or equal, waiting, and then jump back, sync. Now it would be great to be able to put code in here that doesn't matter if it gets called or not. You know, I was thinking to myself, these odd little pixels we seem to get around the sides, maybe I could just clear the screen gradually in here, and then they might only appear for a few frames and be deleted. But you have to come up with a way of counting that frame count, because when it does go to where you want it to, you've got to get out of here and stop doing that. So, and then you've got to also remember where you were when you did that, so you'd have to have another value here cached up. Where did I get to in the screen clearing scenario, for example? Okay, I got to pixel 1750, restart from there when we're waiting again. And it is possible, definitely. I will be adding that at one point, but at the moment I don't understand it well enough, and it's not about that right now. All I want to do is make sure it hangs and waits, and that does that, but we need the sync end label. And once it ends, we just store our current frame count. So we take that same value again, but this time HL is still pointing here, so we'll just load the value of that with A. There were other ways we could have done that. We could have loaded A with this value, or sorry, this. In fact, yeah, there's loads of ways we could have just done that. But that's the way I see it anyway. But in the book, he's done it like that, and I'm going to leave it like that. But the way I see it, that's exactly the same thing. And then, of course, return. So that's it for tools. And now we've got our border set. I mean, it's always a good idea to compile it when you write a bit of code. Although I can't yet because I haven't included the. I mean, it would still compile, but oh, it probably wouldn't actually. Yeah. So yeah, if you're using another compiler or IDE, you may have to put them, and that's completely legal with Pasmo. But I don't do that. There was a reason why I stopped using double quotes. I can't remember now. If you have certain figures in here, certain characters, they start looking weird for some reason when you put double quotes. So that's just on my system with my setup. Rightio. Let's try and compile that. So that's our source. I'll just make it b.tap so I can type it quicker. Compile fine. And we've got our black border. So that's all working hunky dory. Alright. As said, I done halt and then I done sync. And that was it. It all does it for us. We've already set it up. And the next thing I did was I created a draw background routine. No, not called that. God. There we go. It's always good to comment these. So when you're writing the routine, you just bear in mind that that will equal that. We're just doing that same old thing where we're checking for the end, getting out of there when it is equal to the end. Some of this stuff seems to be auto-completing even though I haven't written it. I don't know how it's doing that really, because it's not in the same folder as where I had it before. Anyway, when we end, this is just to add a scroll to the background so that it always scrolls. Again, I'm just moving through this fast and not commenting because we've drawn the background plenty of times, including yesterday. And it was working fine. I have missed out here though, haven't I? So that's when we do hit the end. If we're not at the end, increase the pointer, jump back to the start of this routine. Draw background, yeah. Don't know, it just looks weird, badly spelled word, I don't know why. Probably having a stroke. I'm lacking on smoke quite badly, so it's a new experience for me. It's as simple as that, draw background. So I load HL with 0, and that's just to ensure that they're all 0, H and L. Like I probably could have just loaded L with 0. I'm loading it with the upper byte of the Windows start, and then I call draw background, and that will draw our scrolling background. However, if you notice, it's only drawing to the window memory. The real video memory is untouched. So this is where our big routine comes in. A new file. I've named it playwindow.asm. I'm not quite sure about that name now. And then I put playwindow draw. Now, again, as a note, the exact same note I put before, game area is 16 by 8 character cells. Just as a reminder. We need to create stack pointer. I made it a word. The book does not show you how to do that, but I made it a word and it works, so we'll probably just do that. I mean, I also had it on the bottom, so let's just do it at the bottom. Right, so we have got chunks of code here to write, but I actually managed to write this in about 5 minutes because of copy and paste. So I'll show you how I did it, and it did work well. Hopefully I can do it the exact same way. I'll write seg1, but we're only going to be using one segment, so it's not really needed for this particular project. Character row 0, line 0, scan line 0. Let's make it completely obvious. So again, just to really hit it home, it's only 16 wide. At this moment, there's no margin. It's going to start immediately on the left side of the screen, starting in segment 1, which is a third down the screen. So our origin for our memory is there, roughly. And that's exactly where we are right now. It's only going to be 16 wide. The whole screen is 32, so obviously it's half the screen width. And 8 character cells is one whole segment, which is a third of the screen. And we're at the top left. Right, let's hit home now. We're moving the stack pointer like my other videos recently. We're using every register other than the IX, IY pair, or whatever you want to call them, the true 16-bit ones. Exchange so that we can use them all over again, and shadow registers. All this is the same as what we've already done because this wasn't where the problem was. So I've instantly put margin size. The reason I put that at the front was just because of this find and replace thing. I had to do that really because I want, well, yeah, that's the reason why. We're really wanting to start there. At the moment margin size is 0, so you can basically ignore it. But that will allow us obviously to move from here. We can just add a 5 margin or whatever, and then it's going to start from there. Plus window width. which is 16. Because if you remember, this one goes backwards, so we have to draw. We're going to push at the very highest part first. So we've moved it forward 16, and now we'll pop it back, or push it back actually. This low stack pointer need a little something. Look at SP. Yeah, I expect it does. It doesn't look right if I've got, yeah. Yeah, I forgot. I just started chatting, didn't I? That will need an SP. Very correct. Well done. Lucky I got you around in it. Could have been there for ages. Well, probably would have found it. Can just imagine myself being there for absolutely ages, figuring out why it's not working, changing all these around. We've just done the whole scan line 0 because we're only doing half of the screen, and there's 16. We've just moved 16 bits, or bytes in fact, from our memory. We've copied it all the way to here, backwards. Scan line 1. And actually, this is so similar to yesterday. I may copy all this in and quickly run through it. I really think that's going to help. I don't want to lose anyone. Like, I think if I copy it in, yeah, I'll do that, and then I'll talk us through it, because it is still one hell of a lot of lines to write here. Just copy the whole thing. So I've called it stack point. That's exactly the same, isn't it? Here is where we were. So we've stepped forward that L1 256, because if you remember, it does line 0, then it goes down a whole character, line 0, and it does that 8 times. Then it goes back to line 1 of character cell 0. So we've added 256, which is how far away it is. And I've written this in such a way that you can just multiply window width offset by the amount of lines. But of course, as you keep going up, you never go back to the start of that memory. You're always going up by one whole window width. But that's not the same as this one, where because it's already got them offsets, and just the way it works, it's just very strange. But that remains the same every character cell down. You just add a C1 offset as well as all that, and then when you get to line 2, oh, see, it's not line 1. That's why I started calling it scan line. When you get to character line 2, that's where you get your C2. So it's all the way there. So, but it makes a lot of sense, this, to me. I've written this, as you know, about 5 times now, and it really does make sense how it works. I get it now. I mean, I'd hate to write an algorithm to do this. Doing it manually is much easier for me. But of course, this is only a small window. If you do a big window, you've got to do a lot more of these manually. But that's why I chose to do a small window, because that's, believe it or not, a very small amount of code for someone to look through, figure out what's happening. Before, for each line, we were having to do all of that, then move this forward another whole half, and then do it again, you know. And it does work. I'm pretty certain that code we done yesterday works. And now I'll get to the bit where we actually needed to change, which was our draw sprite. Obviously, if anyone has any questions about what I just skimmed over, please let me know. In the 4 hour special, yeah, exactly, man. I mean, I completely understand that people aren't going to sit there and watch through that entire 4 hours, because unless you're really enjoying it, there is a lot of babbling there. So you're probably going to try and skim through to see when I'm changing code, and it could probably get frustrating. So I'm a bit gutted about how it ended up, but I did specify that it's live code in session. You know, it's not like an actual lesson or a tutorial or anything. But yeah, let's do the draw sprite. Oh, of course we've got to create a sprite, and I'm going to do it in its own file. I'm getting into the habit of doing this now. In preparation for making a whole game. That's just a face. This time it's like a ninja, you know, he's wearing a mask. You can only see his eyes and a little bit of mouth. Probably a bad choice. I should have done like a flag like last time, because it pops better against the background, you know. But let's leave it for now. God, I've got a massive great moth here again. Hopefully it don't fly in the microphone. Before I forget, I'll include those. And as you can see, some of them I've done. That was what this compiler done for me automatically. So maybe I should start using double quotes actually. But anyway, it'll work. Okay, finally we're getting down to it. I think it'll be an anticlimax when we do get to it, because it's such a simple thing. Okay, so BC equals sprite pointer. Again, I'm just ensuring H and L are both 0. Take player Y. Oh, I tell you what. That's what I did. I didn't create sprites in the end. I went against that. Decided against that. I just created a player.asm. And I put the sprite and the variables in that. So that sprites isn't needed. Yeah, now we can have all the player logic in here. And data, you know, properties. Yeah, so I took player Y into A. Why was I doing that again? Oh yeah, that is exactly where we went wrong in our code, I believe, before. Because we were timesing by 32 the whole time, and I don't think we changed it back. And as it happens, luckily we're changing, but we're doing exactly 16 this time. So we can do add HL, the same sort of caveman multiplication we can do. It's going to work fine for us. The reason I'm doing this, in case someone's new to programming and hasn't worked with 1D and 2D arrays, if you picture an array, how can I explain this really quickly? Well, first I'll put the formula there. So what we want is we want a position. We've got a 2D grid of pixels. When we look at a screen, we can visualize that, can't we? Yeah, anyone can visualize that. Now, if you say I'm on the X position 5 and Y position 3, you'd expect to be sort of 5 units along and 3 down, yeah? That's a 2D array, you know, that's a grid. And we've got a 1D array of pixel memory. It's just in a straight line. Now, the way of converting that would be if I just put pixel address or pixel mem address equals base mem address plus our y coordinate times by the width of the table. Whatever an array is basically a table, yeah, like a 2D array. Plus our x coordinate. So our x is just an offset, and so is that. All we really care about is that. Then we can just add those. And I hope that makes sense, because if you've got a grid 10 wide and you're on 1x and 1y, you have to times y by 10 to get the width, and then add the extra 1x to get where you actually are in that memory. That's the only reason that's like that. And we want to get to 16 because our width is 16 and this is our y. And there it is. And we before had that because I'm so used to doing 32 because we were working directly in pixel memory, which obviously spans the entire screen. And I was just so used to that I'm pretty sure I had that there. I didn't have these comments. Anyway, this now works because I got home and tested it before I came online. So I play Windows Start, the full size byte, 2 byte address. Add it to HL. Again, just doing it 0. I'm not sure that's always necessary, but it makes me know that it worked. It's not, messing up. So I just wanted to make sure that D and E were both 0 at the time, because here I load E with A, which is player X, and then now we can just add HLDE. So you see where I am in my code. Yeah, and now you'll find HL equals that, which is what we want. But of course that only points to the first byte of it's basically the origin of the sprite. We've got that one down. So what we do is, and I like to comment these whenever I'm going to copy and paste. I do a lot of comment. It's just a habit for me. So that's the 0th line of the sprite, and it's only an 8 by 8 sprite. 1 byte by 8. So we don't have to mess around like we did before, which just added another layer of confusion when we were trying to debug. So instead, this time, we just inc BC. BC is the pointer of the sprite, so we just want to move 1 byte across. But with the HL pointer, we actually want to move an entire window width. Again, just taking us down 1 whole row, basically. So we were either making it 32 there, or we were using a constant there. Oh, happy birthday, Moz. Yeah, good for you. Older is nearly always better, in my opinion. You got some beer. Get on. Do you know what? I haven't drunk alcohol in quite a long time, But I was genuinely thinking of doing a stream that was like a virtual pub and only pub games. Like there was going to be darts, pool, poker, a couple of other. I had some cool games in mind that were actually set in pubs. Bullseye. Yeah, I thought that would be a sick. And then I haven't got a face camera or anything, but I was gonna like have a beer on the go while we were doing the stream. No limit. Oh right, when you hit a certain age, it goes back down. Peaked. I feel like I peaked quite a long time ago. I'm 38, but I'm content. That's what I mean. The older you get, the more content you become. That's what's happened to me anyway. Lovely. I've actually got a bottle of Jack Daniels sat right in front of me, but I don't want to drink it just yet. Yeah, bullseye. I was so close to doing it. If I hadn't have figured this out, I was going to do that. It was going to be a pub, like the virtual pub, and I was going to put like the title, "Come and have a drink with me in the virtual pub" or something. We'd be playing like Bullseye, 180. I've actually got the list written down. Let me see if I can find it. Oh, the fruit machine game, snail racing, poker, 180 darts, EastEnders. I had a whole list written down to play. I probably will do that as well on a Friday night or something. Yeah, so basically we'd failed by either doing the wrong multiplication here or we were moving the pointer too far forward. But this time I've made the constant and it's definitely right. Oh, so you're 48. Oh yeah, 1972, of course. I tend to go to the doctors more these days. Luckily, I avoid doctors like the plague and it's, not hurt me so far. I'm just rolling my last cigarette here. Well, it's beautiful weather to have a birthday on, wasn't it? It was absolutely roasting here. I think it was like my friend, well, he's not my friend, he's my boss at work. He's Turkish, and he said it was hotter here than it was in Turkey today. We had 32 or something, and they had 29. It was too hot for me. I was driving around in my car all evening. Oh, hello. I added this poll ages ago. It's just popped up. What the hell? That's funny. Yeah, it's bacon. The doctors love you now. Yeah, that's sad. Once they get their claws into you, you're done for. I noticed it with my mum and some of my other families. You can never get away with them from them then. Yeah, I'm down in Torquay. It's a nice enough place, but it's pretty cruddy. Pretty cruddy if you ain't got money. But like most places, it's hard to get money here because there's like lots of holiday makers splashing money around. So shops are quite expensive to buy things, and the wages are terrible. But my job's actually okay. But I do have to pay car repairs and stuff like that. That hits me like a bloody brick when I'm not expecting it. Oh, I was born in Sussex, East Sussex, but I've never been up north. I went to Scunthorpe once to pick up my mate's girlfriend, and I drove all the way from Torquay to Scunthorpe, picked her up at about 2 in the morning. We got there, turned round, and instantly drove back. That was the most insane drive I've ever done. I think it was something like 750-mile round trip without stopping. And I'd also been at work all night. He phoned me at like 10 o'clock, 11 at night, and I said, yeah, alright, not knowing where the hell Scunthorpe was. I think it was somewhere near Newcastle though, because I think it said like Newcastle this way, stuff like that. When I got there, it wasn't that far. West Sussex. Cool. Yeah, that's brilliant. I don't know any of the area except for Hastings where I was born, but I don't really know that, not that well. We've done one bite there, and I think I'm going to use the old, here's one I prepared earlier, trick, but I won't just copy over, I'll copy just a bit in that I'm missing. You posh these days. Yeah, you probably couldn't get away with being posh up in the northeast. No one I've met from the northeast has been posh, put it that way. They know how to drink up there. I know that. All the people I know from Newcastle. Wow, they hammer it down. All I've done here is I already done that bit, and I've copied in everything after that, which is just that. All it does is we've moved the pointer to the next piece of the sprite. We've moved it down a whole line, and we've done that 8 times. Obviously, on the 7th one, which is the 8th, we don't need to increment the pointer because that's the end. So we return. Background is something we used and didn't create. What I ended up going for was 1100 1100, and it's scrolling. I'm gonna get rid of that. That was just to demonstrate to people who don't know how to convert a 2D array into a 1D. Because I can remember when I first learned that, it was like a eureka moment for me. I used to do like nested loops all the time in C, all the different variations of C and Java, and then I realised you could just use that bit of math to get to the right element in the array. I don't know why I did that because I actually like this space being there. I believe this is good to go. So there's our meat. We've got a return at the bottom. Yes, it does. Now, another thing that I've never touched on in any of my videos is we're declaring all of our variables as global variables. And I used to do that when I first started coding in Java, every different language. But after many years of experience of coding in managed languages and C++, I never make global variables. Do you know what I mean? Ever. It's like people have a go at you for it. Every time you post some code for help, they're like, by the way, you got global variables, blah, blah, blah. Now, I can't think of a way around that in this. But I did read some